1 video lesson. Today we are starting our methods for solving systems of equations. Okay, so a system of equations is two or more equations with the same variables. Okay, so x plus 3y equals 9 and 3x minus 4y equals 8. When listed together, that constitutes a system of equations. Okay, the solution to a system of equation is the ordered pair, or it can be multiple ordered pairs, that satisfy all of the equations. So that means when an ordered pair is plugged in to both equations, they result in a true statement. Okay, we have 3 methods for solving systems that we're going to look at in this unit: graphing, substitution, and elimination. Okay, today we're just going to focus on graphing. So there are 3 different scenarios that your problem could result in when graphing systems of equations. Okay, the first scenario is you get one solution. Okay, so you would be given your equations and you would graph each of them on the same coordinate plane like you see here. Okay, one equation is the red line and the other equation is the blue line. Okay, and these graphs are going to intersect at exactly one point. Okay, and that ordered pair is the solution to your system. So that ordered pair could be plugged into each of those equations and result in a true statement. So in this scenario, the solution is 3, 0. Okay, scenario number 2, you could have all solutions. So we've seen all solutions when we've solved various types of equations and inequalities. Okay, so I would graph my 2 equations on the same coordinate plane. So the red line, it would be my first equation. And now the blue line is my second equation. And I see that they represent the same exact line. Okay, so 2 lines on top of each other are going to intersect at every single point that is on the line. So that means that we have an infinite number of ordered pairs that satisfy both of those equations in the system. Okay, so the solution to a scenario like that is all solutions. Okay, scenario number 3. When we graph our 2 equations, the lines never intersect. And if the lines do not intersect, we cannot get a solution. Okay, now the only way that we could get lines that never intersect is if they were parallel. Okay, and what do we know about parallel lines? The equations have the same slope. Okay, so the solution to a situation like this, where the equations never intersect, is no solution. Okay, so if any other scenario is your result for a system, you want to go back and check your graph. Okay, now in addition to knowing how to give the solution, okay, we also classify the system based on the number of solutions they have. Okay, so our first classification is called consistent, and we use that to describe a system that has one or more solutions. Okay, we then have 2 different kinds of consistent systems. Okay, we have consistent independent, and that is for specifically one solution. We then have consistent dependent, which is specifically for infinite solutions. Okay, so the scenarios that we're referring to for consistent and independent would be when you have 1 point. Consistent dependent would be when you have all solutions because they are the same line. Our third classification is inconsistent, and that occurs when there are no solutions. So that situation would be for parallel lines because they're never going to intersect. Okay, let's try a few examples and see how we go about doing this. Okay, so when we are graphing, we have to first make sure that our equations are in slope-intercept form. So that means to solve for y. And then we're going to graph our two equations on the same coordinate plane because we need to see if and where and how they intersect. Okay, we need a graph to determine our solutions. That's how we tell. So we read the graph, okay, and we either give the ordered pair, we say that it's all solutions, or we say that it is no solutions. And then we're going to classify our system according to the number of solutions. So those 3 terms that we just talked about. All right, so our first example, we have our 2 equations, y equals negative 3x plus 6 and y equals 2x minus 4. Okay, we're going to graph each of those on the same coordinate plane, and I'm going to color code according to the equations. So my first equation, I'm going to begin at 6 and move down 3 and over 1. Okay, and you can see I am filling up the whole graph here because I don't know where my lines are going to intersect, and I want to make sure that I have the exact points where the lines are going to hit. Okay, use a ruler to connect. All right, now I'm going to do my second line in blue. I'm going to begin at 4, and my slope is up 2 over 1. Okay, and I can see that my lines just hit there. Okay, so I'm connecting that as well. Okay, so now we want to state our solution. So what is the ordered pair of the solution? Where do the lines intersect? Okay, my solution is 2, 0. So I have one solution. How do I classify that system? Consistent and independent. Okay, so your answer has 3 parts here. You have the graph, you have the specific solution of 2, 0, and then you have your classification, consistent and independent. Okay, our second equation now, our second system, I'm looking at this equation and I see that this is not in slope-intercept form. So I need to solve for y. And I'm going to keep the plus 0 so I know where to begin. Okay, but that's the form of the equation that I'm going to graph now. All right, so my first line begins at negative 3, and I'm going down to over 1, or up to and left 1. All right, and I'm going to connect. Okay, and my second equation starts at the origin and again goes down to into the right one. So if you noticed before we even started, each of these equations has a slope of -2. Okay, and what did we say about equations that have the same slope? Those are parallel lines. So we know parallel lines will never intersect. So what is my solution? What is the ordered pair of the solution here? There isn't one. Okay, there is no ordered pair because the lines do not intersect. So my solution is no solutions. And we classify a system that is no solution, parallel lines, as inconsistent. Okay, the system is inconsistent because these lines are never going to touch or intersect, and the only way you get a solution is if they intersect. Okay, and our third example. So my first equation in red is in slope-intercept form already. My second equation does need to be solved for y. Okay, and if I compare my two equations, I see that they are exactly the same. They both have a y-intercept of -4 and a slope of 1. Okay, so when I plot these, they're going to be graphed on top of one another. Okay, so what is the solution? If they intersect at every single point on the line, what is my solution? All solutions. Okay, and we classify a system that is all solutions as consistent and dependent. Bring that graph back up. So it's consistent and dependent because they are all solutions. They're the equations of the same line. Okay, so not a whole lot of new information. Really, the only new thing was the classifying terminology. Okay, so I hope everybody did well with this. Please make sure your notes are complete and you write down any questions that you have. Thanks for watching.